If we were not in the middle of a pandemic, I would have loved to welcome you all at the NCC physically and give you a proper, physical and in-person overview of the facilities we are fortunate enough to have at the center. Considering the current situation, this slide pack will have to do. My objective today is just to give you a taste of what you might be able to see and hopefully see working if and when you decide to join us for the the full-blown edition of this conference in the hopefully not too distant future. So for those of you who don't know me, my name is Giuseppe Dell'Anno. I'm a chief engineer at the National Composites Center. This presentation should have been given by the chief technology officer, Enrique Garcia, but unfortunately, due to force majeure, he was forced to ask me to step in this very morning. So he is fine. Nothing serious happening there. But there has been a clash with the COVID testing for flights and everything that is required by the current restrictions and regulations. So you will have to be you will have to do with me, I'm afraid. So just to give you a bit of a landscape outline of where the NCC sits in the UK, we are an RTO that, together with other 6 centres, form the high-value manufacturing catapult. So the catapult networks have been established by the UK government a few years back. There are 10 catapult networks in the UK. You can see the list on the bottom right corner of the slide. And the objective there is effectively to bank and build on the areas where the UK has been recognized to have strength from a research perspective. The NCC belongs to the high-value manufacturing catapult, one of the 10, and the 7 centres across the country are dotted around the landscape, as you can see on the map on the left-hand side of the slide. We are a part of a very large crowd of people. There are over 3,500 researchers and engineers working for these 7 centres, and we make available over £700 million worth of assets to the universities and to the industry in the UK. The centres are all open centres, so we strive to be able to offer everybody an opportunity to test technologies and to do research on technologies using the asset that we can maintain thanks to a generous government funding that us for one of our budget on a yearly basis. The space in which we focus our research and attention is the so-called Valley of Death, so TRL 4 to 6. We can do that thanks to the very strong links we've got with the industry at national and international level. More recently, we have focused our attention on the front end of that Valley of Death, so the TRL 3 to 4, because we have recognized that although the entirety of the Valley of Death is an area that is very likely to see the demise of innovation, that particular interface where the academic research stops and the industrial research should take over is a really, really critical area that requires attention and focus, and is relatively difficult to handle because of a whole set of reasons that go from funding to mindsets, etc. So we are focusing our attention in that space, not just at NCC level, but also at broader catapult network level. From our perspective, we address that challenge by creating very strong links with the Future Composites Manufacturing Research Hub, or SIMComp, which is a hub of funded by the EBSRC in the UK, focusing specifically on composites manufacturing. And we have the opportunity as a National Composites Centre to have a stake in the definition of the direction of the research at SIMComp level, as well as having the opportunity to see firsthand the phenomenal outputs that the UK universities are generating thanks to that frame. Just to give you a bit of an overview of what the NCC looks like in terms of numbers, together with the 150 research engineers that the University of Bristol has got here locally, just next door to us, the 350 composite engineers at the NCC form the largest cluster of composite specialists in the Western world. And it's something that we from internally at the NCC were almost used to, but it certainly generates a critical mass that attracts a lot of work, a lot of research, and it's made the NCC grow steadily over the last 10 years. We were only open 10 years ago. In July, we're going to be celebrating our 10th anniversary, and we have reached this milestone with two sites in Bristol, one in Filton, one in Emerson's Green, for a total of over 21,000 square meters of office and workshop space. What I'd like to do now is to give you a bit of an overview of what are the big plays, if you like, at the NCC, what are the big chunks of activity that are keeping us awake at night these days. Certainly, digital engineering plays a big role in that space, and I've got on this slide a couple of programs, probably the largest programs we've got at the NCC currently on digital engineering. Both of them have got as an objective the aim of re-engineering the engineering process, if you like. So building on the engineering knowledge that today exists in the composite space by adding that thread that joins up the dots, essentially, and enables unlocking the big potential behind the process modeling and the knowledge of the process and the material modeling, etc. We are doing that through these two programs. The first one, DETI, which stands for Digital Engineering Technology Innovation, sees the NCC as part of a much broader consortium, and together we are developing 5 enabling capabilities articulated over 4 large industrial use cases in a matrix fashion, as you can see in the illustration over there. The objectives and the aims of DETI are to widen up the diversity of people that are engaging with engineering, provide the skills and the capabilities for the engineering of the future, and also upskill the current workforce to give them the tools to be able to to swim in the sea, in the new digital sea. The 5G Encode program is very much hardware related, at least in the initial stages, in that the NCC is becoming part of the very first UK industrial 5G testbed. We are being literally hooked up to a network that is going to be a 5G network, and the purpose of that is to be able to locally test and understand what is involved into the safety of the network, so that we can provide the underpinning capabilities for the digital engineering to bloom effectively. So provide channels for the information to be exchanged securely, readily, and fast. And the other area that we are focusing our attention on, for sure, is the sustainability aspect of composites. This is an area that we've been active in for a long while, but over the last, I would say, 2-3 years, it's grown to the point that we have dedicated effectively a special business unit to this activity. And the philosophy, I suppose, behind the attention towards sustainable composites is the realization that we need to shatter the glass ceiling that otherwise would dwarf the growth of composite in the future because of the very chemical nature of the polymeric matrix composites. And the way we're doing this is by addressing both the constituent materials, therefore looking at, for example, sustainable fibers, recycled fibers, bio-based resins, etc., as well as, first of all, being able to assess properly the life cycle of composite components and redirect, possibly remove altogether the big issue of what to do with the end-of-life components once they are dismissed and taken out of service. This area is brimming with activity. We have put together a partnership with one of the other 6 catapult centers, CPI, in order to be able to have that link between the material formulation development that CPI is looking after and the manufacturing process optimization that we are looking into. And if we didn't have to do this virtually behind the screen, I would have liked now to show you the very facilities that you can see on the screen right now in our headquarters in Emerson's Green. Unfortunately, we have to stick to pictures for the time being. I suppose the big message behind these slides is that I've lost count of the number of robots we have installed at the NCC, the number of gantries that we've got moving around our workshop. The message there is that composites manufacturing in the future is all about automation, and this automation in the space of material deposition, automation in the space of material handling, automation in the space of preforming and local reinforcement of materials. What you're looking at in the slides on the left-hand side of the slide is one of the largest pilot line for the deposition and the handling of preforms. In this particular case, it's what we've been using with the work we've been doing with Airbus for Wing of Tomorrow that you've heard everything about yesterday. Other systems that you're probably more familiar with and are less bespoke, perhaps more readily available off the shelves, are the ones that you see on the right-hand side. Coriolis system for AFP and material deposition, systems, KSL systems for materials reinforcement, stitching, zeppining, and tufting, as well as bespoke systems for small plies handling and movement throughout the manufacturing process. Other more perhaps niche areas where automation still plays a very significant role is in very bespoke material shaping and formation. We've got what you're looking at there on the left hand side of the screen is our brader, one of the largest braders in Europe, accessible in an RTO, in a research center. Is a double ring brader capable of depositing material on mandrels up to 750 millimeters in diameter. We are not looking only at manufacturing, the manufacturing space, but in the top right corner of the slide, what you're looking at there is our CIVC system, which is a robotic unit for the quality assessment of large components, for the automated assessment of large components through systems like thermography and C-scanning, etc. We're not looking only at prepreg and infusion of thermoset resins, but we are also pushing strongly in the thermoplastic space, and the overmolder, the angle overmolder on the bottom right corner of the slide shows the equipment that we've been playing with recently. However, most of the development in that space is, as the previous speaker was mentioning, very much on the material performance, long-term material performance side, the material formulation aspects, as well as the process modeling. And we've got lots of things to say and that I would love to share with you guys in terms of modeling the process behind the overmolding technology. One of our most recent acquisitions is another jewel in our crown, is the Electro impact machine. Another material deposition system is an AFP ATL machine. The peculiarity of this machine is that it's got a broader range of tapes that we can play with, and crucially, they can be changed throughout a single deposition, because the machine can drop and pick different deposition heads with the appropriate crills. Therefore, we can use on the same component tapes that have got different size and different formats, thereby optimizing the material deposition rate. There is a small link in this slide pack, which is also on the ACM5 website, just right under my name. So I would encourage you to have a look at it if you want to see this machine in action. And that's it from me. I hope that gave you a flavor of what we would have liked to show you around our facility, and I'm really looking forward to be able to do this live perhaps with some nibbles in a few months' time. Thank you for your time.
Thank you very much, Giuseppe. And we are running a bit over time now, and I hope that's okay for everybody. There is one question, and if we can try to answer quickly, Giuseppe,
I'll try.
I'll read it up for you. It's from Carl Lisson, and he says, "Hi Giuseppe, great to see you again. Where do you see our composite engineers from the future coming from, and how is the NCC trying to get the word out there to schools?"
Yeah, well, our STEM activity is very much alive and kicking. We've got a few people, there is an entire team at the moment at the NCC fully dedicated to just that. And I'm glad to say that we have been able finally to reopen the doors to our graduate scheme, to our young early career development scheme that was put on hold last year because of the pandemic situation, but we put a lot of effort into developing our engineer. The question from Carl is very pertinent in that what we are seeing these days at the NCC is that the composites engineer of tomorrow might not come entirely or exclusively from a composite materials education background, especially now while we are moving towards new sectors and we are trying to push push is a bad word. We are trying to invite new sectors to exploit the advantages of using composites over more conventional materials. We are opening ourselves up to new vocabulary, to new interfaces that we're not used to. Examples are the construction and infrastructure sector, for example. There is a huge untapped potential there, but we, or RTOs like us, have to bridge the gap in order to be able to reach out to these people. And necessarily the composite engineers of the future need to be able to understand the language that the new sectors speak. Therefore, not unsurprisingly, we are hiring and recruiting composites engineer in that space that have some understanding of civil engineering, for example, so that when the time comes to discuss certifications behind construction and infrastructure, they can speak the same language with the potential user of the technology. That should have been a short answer. Sorry, it went on.
It was a comprehensive answer, if not short. So thank you very much, Giuseppe. And in the interest of time, I think we need to move on to the next agenda point, which is the panel discussion. So once again, thank you, Giuseppe.
Thank you, Ole.